or smart factories. Before diving deep inside the Industry 4.0, let us look in the past to understand how the manufacturing revolutions evolved to shape the production. The manufacturing sector has seen three major revolutions so far that improved the production processes and productivity. In the first revolution, machines and trends were driven by steam and water, whereas in the second revolution, the same were driven by electricity and power-driven assemblies. This led to the faster transportation. Since then, traveling became easy and the world became smaller and smaller. In the third revolution, computers, electronics and telecommunication, and IT played the key role in data exchange and information sharing. This triggered the automation, improved the process efficiency, and increased the productivity. Like earlier revolution, Industry 4.0, the fourth revolution that we all are going through, is for the betterment of factories. The fundamental principle of Industry 4.0 is to create the factories of the future or smart factories that will have intelligent networking of machines and processes for industry with the help of information and communication technology. A combination of cyber physical systems, the Internet of Things, and Internet of Systems make Industry 4.0 possible and a smart factory a reality. So Industry 4.0 has different names in different geographical regions. You can see on the slide, in Germany it is called as Industry 4.0, whereas in the United States of America it is known as smart manufacturing. In China it is known as made in China, whereas in India we call it as make in India or digital manufacturing. Industry 4.0 is basically a combination of 9 major technologies, and those 9 major technologies help to create smart factories. The amalgamation of these technologies will form smart factories for the futuristic production, and this will help to reduce human fatigue and will introduce more and more automation, robots. With the help of these, all the productivity as well as production will have a digital data that we can use to resolve all the limitations, all the problems for a ever improving technological world. These 9 crucial modules are in front of you, and you can see that autonomous robots, simulation, system integration, Internet of Things, cyber security, cloud computing, additive manufacturing, augmented reality, and big data. These are the very crucial technologies. You must be familiar with this technology, or you must have heard about this technology in brief or in depth. But how these technologies help Industry 4.0, rather the companies trying to implement Industry 4.0, that is what we will see in the session today. Industry 4.0 is driven by digitization. Platform Industry 4.0, a German initiative with 2030 vision, is on a mission to create global digital ecosystem. For this, German government and industries have identified 3 crucial features, which are autonomy, interoperability, and sustainability. Openness and globalization of digitized industry are the main visions. Above all, this requires open, interoperable standards, common IT security solutions, and suitable regulatory frameworks. With this vision, autonomy stands for a free scope of design which guarantees competitiveness and self-determination of digital business models. Interoperability is the basic requirement for cooperation and open ecosystems, permitting plurality and flexibility. The concept of sustainability emphasizes modern industrial value creation, which ensures a high standard of living. The vision reflects European values and is key to securing global competitiveness of German companies. The same can be replicated across the globe for better future and productivity and for betterment of companies. Such digitization is further subcategorized as digitization and integration of vertical and horizontal value chains, which is nothing but connecting all the departments of companies in a vertical integration, through vertical integration. Industry 4.0 is through digital connectivity, integrates organizations vertically. All the departments are interconnected. With the help of augmented reality, all the data from departments is available in real time for appropriate use in an integrated network. Horizontal digital connectivity goes beyond the organization operations from suppliers to customers and to all key players in a value chain. These are connected through track and trace devices and real-time integrated planning with execution. Further, digitization of product and service offerings. Products are digitized by adding sensors or communication devices that can communicate with data analytics tools. The main focus of digitizing the products is to ensure completely integrated solutions. Such integration helps to generate data on use, product use and refine products to meet the increasing needs of customers. The third subcategory is digital business models and customer access. Industry leaders are providing disruptive digital solutions such as complete data-driven services and integrated platform solutions. These solutions are mainly for generating additional digital revenues and optimizing customer interaction and access. Digital products and services mostly work to serve customers with complete solutions in a distinct digital ecosystem. This is how the data flow and interconnectivity among devices will be ensured in Industry 4.0 environment. Be it small or big business, everyone will go through this structure to improve the productivity. Sensors and other devices from physical world are interconnected through virtual networks. Intelligent systems are crux of the digital production. These are also known as smart systems. The word smart symbolizes combination of equal tangible and non-tangible goods with digital systems. These goods communicate with each other intelligently across the network to ensure data availability across vertical integration. Further, such systems ensure smart factories, smart products, and smart services. Let us just go through these entities to understand what is the meaning of smart exactly. Smart factory. These are basically adaptive production systems that are networked using software and interconnected by various value creating systems. Operators get live data about the work, machineries, and factory atmosphere instantaneously that helps to take necessary actions if needed. Network and real-time capability as well as scalability are crucial factors for most secure and predictable exchange of data or information between devices and services involved. On the basis of decentralized intelligence, these scalable architectures can make their decisions by themselves. This is how the factories are becoming smarter and smarter. Smart products. The Industry 4.0 is not limited to factories. Implementing Industry 4.0 technologies, products can become smart too. Smart products do more than actively control their own production processes. Once they are delivered to a customer, they serve as a platform for new business models. In the future, there will be billions of smart products that are connected to the internet throughout their lifetime and will save huge amounts of data on their own operating conditions and product states in the cloud. All the data they have collected can be used to optimize the products. Moreover, intelligent algorithms can link existing data with new information, that is intelligent data. Smart products can flexibly adapt themselves to as per the consumer needs and can also be a part of other systems through intelligent networking. For example, by storing a configuration data on a component or module, successful commissioning of the machine can be conducted in timely manner as there is no need to have manual setup measures. Smart services, a combination of virtual and physical services that provide valuable services to the customer are referred as smart services. Smart products and smart services complement each other or work hand in hand. These are also known as agile services as they provide flexible market orientation every time. Network software environments that are embedded in the services form the basis for smart devices and smart services. One example is remote monitoring. Things that have sensors or RFID chips are trackable. This helps to trace the exact location of the product in the supply chain system. This is widely used in the field of logistics and increases competitiveness and organizational capabilities. So these are basically digital systems that form a digital network in Industry 4.0 environment. Industry 4.0 includes many digital technologies to create smart factories. The knowledge of these technologies is crucial for the betterment of companies that want to strive and sustain successfully in the ever-evolving technological world. So first and foremost is cyber physical systems or industrial Internet of Things. These are the major building blocks of Industry 4.0. With these systems, internet and physical world will be connected to transmit the real-time data to improve the overall factory or company performance. Such systems ensure transparency in vertical and horizontal integration of companies. The real-time data is available for all the stakeholders to process as per their needs. In the industrial world, these systems are referred as Industrial Internet of Things or IIoT systems. In IoT world, IT systems are also part of the network and hence they are also called as cyber physical systems. This is mainly achieved through the augmentation of physical devices with middleware that implements popular IoT protocols. Overall, cyber physical systems and IoT systems will be at the core of Industry 4.0 deployments in years to come. 5G communications. In its early days of implementation, Industry 4.0 was supported by 4G or LTE technologies or Wi-Fi technologies. Those were capable of handling the data as the number of sensors and devices connected to the network were relatively less, and hence data collection was not much. But as the implementation process across the globe has started picking its speed, the more and more devices, sensors, actuators, and alike ones will be a part of the implementation process. And they need to be connected with much stronger data processing network. Further, the amount of data generated from factories and other products will be humongous that need dedicated networks. 5G technologies have started knocking the doors as telecom companies have embarked on testing 5G technologies. In particular, 5G technologies will enable low latency data acquisition from thousands of devices at plant scale, which offers spectrum efficiency and ease of deployment. Low latency means a computer network that is optimized to process a very high volume of data messages with minimal delay. Low power wide area network. In recent years, low power wide area network technologies have emerged in order to support IoT devices connectivity at scale, notably the connectivity of low power devices. These technologies offer flexible and cost-effective deployment while at the same time supporting novel applications in both indoor and outdoor environments, including the accurate localization of items in indoor environments. There is a possibility that such technologies will also be used in order to provide location as a service capabilities in industrial plants. Their deployment will come to enhance rather than replace the connectivity capabilities that are currently provided by 4G and Wi-Fi technologies, notably in the direction of accurate item localization that existing technologies cannot deliver. Cloud computing, CPS manufacturing systems, that is cyber physical manufacturing systems and applications are very commonly deployed in the cloud in order to take advantage of the capacity, scalability, and quality of services of cloud computing. Moreover, manufacturers tend to deploy their enterprise systems in the cloud. Likewise, state-of-the-art automation platforms are cloud-based. Soon we will see most manufacturing applications in the cloud yielding cloud computing infrastructure, an indispensable element of Industry 4.0. Edge computing. During the last couple of years, cyber physical systems and industrial Internet of Things deployments in factories implement the edge computing standard. The latter, that is edge computing, that is IoT deployments in the cloud, complements the cloud with capabilities for fast, that is nearly real-time processing, which is performed close to the field rather than in the cloud. In an edge computing deployment, edge nodes are deployed close to the field in order to support data filtering, local data processing, as well as fast, that is real-time actuation and control tasks. The edge computing paradigm is promoted by the major reference architecture for IoT and Industry 4.0. Those architectures are Industrial Internet Consortium Reference Architecture, that is IIRA, and Reference Architecture of the Open Fog Consortium. Big data. The vast majority of Industry 4.0 use cases are data intensive as they involve many data flows from multiple heterogeneous data sources including streaming data sources. In other words, several Industry 4.0 use cases are based on data sets that feature the four V's, that is volume, variety, velocity, and veracity of big data. Predictive maintenance is a classic example of big data use cases as it combines multiple sensor data with data from enterprise systems in a single processing pipeline. Therefore, the evolution of big data technologies and tools is a key enabler of the fourth industrial revolution. Industry 4.0 is typically empowered by big data technologies for data collection, consolidation, and storage. Given that industrial use cases need to bring together multiple fragmented data sets and to store them in a reliable and cost-effective fashion. However, the business value of these data lies in their analysis, which is indicative of the importance of big data analytics techniques, including machine learning and data learning techniques. Artificial intelligence. Even though there is a lot of hype about the use of artificial intelligence in industry, most manufacturers and plant operators are familiar with this technology. Indeed, artificial intelligence has been deployed in industrial plants for over 2 decades in different forms such as fuzzy logic and expert systems. In the Industry 4.0, the term is revised and extended in order to include the use of deep learning and deep neural networks for advanced data mining. The use of these techniques is directly enabled from the big data technologies. Hence, they have very close affiliation with big data as deep learning can be used in conjunction with big data technologies. Artificial intelligence data analytics is more efficient than conventional machine learning in identifying complex patterns such as operation degradation patterns for machines, patterns of product defect causes, complex failure modes, and more. In industrial environments, artificial intelligence can be embedded not only in digital automation systems, but also in physical devices such as robots and edge gateways. Augmented reality. Augmented reality, that is AR, is another technology that has been used in plants since several decades. It is also revisited as a result of the emergence of more accurate tracking technologies and of new cost-effective devices. It can be used in many different ways in order to disrupt industrial processes. As a prominent example, augmented reality can be used for remote support of maintenance workers in their service tasks. In particular, with augmented reality, the worker needs no longer to consult paper manuals or phone supports. He or she can rather view online the repair or service instructions provided by an expert. Here, expert means machine vendor from a remote location. As another example, augmented reality can be used for training workers on complex tasks, that is picking or assembly tasks, through displaying them cyber presentations of the ways tasks are performed by experts or more experienced workers. Blockchain technologies. Blockchain technologies are in their infancy, that is in early stages as far as their deployment in industrial settings is concerned. Despite the hype around blockchains, their sole large-scale enterprise application remains their use in cryptocurrencies such as Bitcoin and Ethereum. The Far Edge project is using blockchain technology for the decentralization and synchronization of industrial processes, notably processes that span multiple stations in the factory. However, other uses of the blockchain are also possible, such as its use for securing databases based on encryption, as well as its use for traceability in the supply chain. It is therefore likely that blockchain will play a role in future stages of Industry 4.0, yet it has not so far been validated at scale. Note that in the scope of Industry 4.0 applications, permissioned blockchains can be used like Far Edge instead of public blockchains. Permission blockchains provide increased privacy, authentication, and authorization of users as well as better performance than public ones, which makes them more suitable for industrial deployment and use. Permission blockchains are blockchain networks that require access to be part of. In these blockchain types, a control layer runs on top of the blockchain that governs the actions performed by the allowed participants. Permission blockchains work entirely different than that of private and public blockchains. They are crafted to take advantage of blockchains without sacrificing the authority aspect of a centralized system. So here you can see big companies already have started using blockchain technologies, such the companies such as Apple, Facebook, Google, Toyota, Samsung. So you can see the industry 4.0 applications or technology applications have already been have already started. Companies have started implementing these technologies. So it's high time for every one of us to learn and grasp this technology to become a part of Industry 4.0 and grasp jobs or business opportunities as much as we can. Cybersecurity. Industry 4.0 applications introduce several security challenges given that they are on the verge of information technologies and operational technologies which pose conflicting requirements from the security viewpoint. Any Industry 4.0 solution should come with strong security features towards protecting datasets, ensuring the trustworthiness of new devices, and protecting the deployment for vulnerabilities of IT assets. 3D printing and additive manufacturing. Along with above listed IT technologies, cyber-physical systems manufacturing processes benefit from 3D printing as an element of the digital automation platforms and processes. 3D printing processes can be driven by the digital data of an Industry 4.0 deployment, such as a digital twin of a piece of equipment or part that can be printed. Additive manufacturing processes can be integrated in a digital manufacturing deployment in support of the above listed use cases. For example, 3D printing can be used to accelerate the maintenance and repair processes through printing parts or tools rather than having to order them or to keep significant inventory. Likewise, printing processes can be integrated in order to flexible customize the configuration of a production line and subsequently of the products produced.
Any of
This
that
can
that
greatly
we are initiating is very good. Even in online sessions also and every we conducted sessions in the past and for that also our response was very poor.
Uh,
Hello.
doc, yes,
In
sir.
the past, in the March and April, we were
Sir,
you know,
Rani, sir, your voice is quite disconnecting.
Shall I continue?
Mm, okay, yes, sir. Uh, Participants, if you have any doubt, then just wait for the session to over, then we can carry out. Yes, sir. Please proceed.
Is there any problem?
No, sir. I think they want to ask something, but their voice is quite clumsy.
Okay, so you want to
Yeah.
take the question or shall I proceed?
No, please proceed because I already asked them. Yeah.
This is how the amalgamation of all mentioned digital technologies are helping or will help factories to conduct operations. This in turn will help successfully achieve the vision of smart factories. For these six essential technologies, companies must install to get benefited the maximum. So first is enhanced visualization and advanced simulation. Manufacturing line layouts and testing require time, resources, and capital only to potentially result in waste, unless those operations can be first simulated. Simulation enables to observe operations on an object or environment without having to physically perform that operation, which may damage tangible, that is physical objects. Simulation seeks to take advantage of the digital twin or the digital representation of a physical object. It is often performed during the design phase or before a factory becomes fully operational to see how changes in equipment specification, scheduling, downtime, and maintenance can affect a process throughout the duration of its life cycle. As software and computer simulates the actual environment and provides an optimal solution, that solution can then be reflected in the physical environment to create a closed-loop cyber-physical system. Additive manufacturing. The traditional product development cycle meant waiting anywhere from days to weeks for a completed functional prototype. The advent of additive manufacturing and 3D printing has performed that process, streamlining the early phases of product development at a fraction of the time and cost. While prototypes and concept models can visualize your future product, the advantages of additive manufacturing are not limited to the design phase. Scaling 3D printing into production means one can easily customize the product for each user and minimize material usage to lower the overall cost of the product. What is more, parts fabricated on demand means reduced lead times and minimal buffer inventory, and that makes for simpler and easier supply chain management. Smart automation, it is no longer about a robot arm assembling a product. Now it is about a robot arm giving you better insights into your operations by feeding data into the cloud. The next generation of robots will have sensors that enable them to pull information to better perform their tasks. In return, you will be able to achieve greater operational efficiency and predict your production output with more confidence. Collaborative robots or cobots are able to perceive their environments more effectively. They use sensors to perceive their environment to see if a human is working around them or in close proximity. If they are getting too close to human, they can automatically stop. It is safer to work with them and better for workers because they perform the tasks that are too difficult or strenuous to perform repeatedly by humans. Machine to machine communication. At the heart of Industry 4.0 and modern manufacturing, machine to machine communications are the key to unlocking factories of the future. Traditional hardwired connections between machines on the manufacturing floor are not designed for connectivity, which means these machines inherently require manual assistance from an operator. Machine-to-machine communications present the first real opportunity for touchless line maintenance and one step closer to a fully automated manufacturing environment. Augmented reality. The augmented reality market has exploded in recent years with more than 150 companies in multiple industries, including 50 of the Fortune 500 testing or deploying augmented reality or virtual reality solutions. Use cases have extended beyond the traditional perception of gaming and into enterprise applications. Industrial and manufacturing environments have enormous opportunities to use augmented reality to optimize their operations. One way we can use augmented reality in our modern manufacturing processes is through remote assistance. Imagine having an expert guidance at your fingertips every time we need it in starting a new process or issuing a repair. An operator faced with fixing a machine on the line can connect with experts across the globe using augmented reality, displaying his field of vision for them to view and guide appropriately. Hello?
Yes, sir. I think your PPT is presentation was stopped.
Any
PPT is not
problem?
visible. PPT is not visible, sir.
So shall I start? Shall I share again?
Yeah, sir. Please share it again. Uh, I don't know why such thing is happening. Yeah. Now it's visible. Your screen is visible. PPT is not there.
Agree.
I am unable to share. Stop sharing. Share. Okay. Now, can you see?
No, sir. It's still your screen is there.
I have stopped sharing now, and now I'm seeing share button. So I'm clicking the share button,
Yes.
and now
Can you
I'm
check it in the background that PPT is running? I
Yes,
think some.
it is running. No, but it's
Yes,
not
sir.
taking only. Because the red boundary is not covering that presentation. It is
Uh,
covering only Microsoft Systems window only. To
yeah,
see
sir.
that,
Go. Yeah. Mm, Go into the share, and there you will see multiple windows in the
yes, yes.
bottom side. So share
Okay,
the
can you see
PPT.
now?
Yes, sir. Correct. Yeah.
Okay,
Yeah.
visible now?
Yes, sir. Visible.
Okay, sorry for the disturbance, everyone.
No
Uh,
issues.
cloud, the last technology that every company needs to have is cloud. Introducing Internet of Things on the factory floor requires seamless connectivity and a limitless repository of data. Cloud computing enables you to extract, analyze, and store information that may affect the production line. For the obviously for the betterment. So digital capabilities are vital to move forward with Industry 4.0. Developing them takes time and concentration. A step-by-step approach is important for everyone to follow, but you must move with enthusiasm so that you don't forfeit or surrender the first mover advantage to competitors. So this is the structured 6 steps that one can follow to implement Industry 4.0 in a company. So first and foremost is map out an Industry 4.0 strategy for your company. Evaluate your own digital maturity now versus where you need to be. Set clear targets for closing the gap. Prioritize the measures that will bring the most value to your business and make sure those are aligned with your overall strategy. Gain commitment to those approach from the full range of top company leadership and make sure that commitment is evident to people throughout the enterprise. Start with pilot projects. Use pilot projects to establish proof of concept and demonstrate business values. Not every project will succeed, but they will all help you to learn the approach that suits or works better for your company. With early successes, you can also gain buy-in from the organization and secure funding for a larger rollout. For the early pilots, define a relatively narrow initial scope but incorporate end-to-end concept of Industry 4.0, that is from materials to customer delivery and even after-sales services. Design practically to compensate for standards or infrastructure that does not yet exist. Collaborate with digital leaders outside your company's boundaries. Work with startups, universities, or industry organizations to accelerate the digital innovation. Define the capabilities company needs or you need. Building on the lessons learned in pilot projects, map out in depth the capabilities are required to achieve the goals and development a, blueprint for building or acquiring those capabilities. Include technological enablers such as an agile and highly functional IT infrastructure with well-designed user interfaces that can propel your business processes forward. Also include strategies for recruiting and developing the right employees and attracting the right companies to work with. The success with Industry 4.0 will depend on the skills and knowledge one can deploy. Become an expert in data analytics. Success with Industry 4.0 depends on the prowess in unlocking data possibilities and using analytics in creative and effective ways. Establish cross-functional analytics capabilities tied closely to the strategic priorities of the whole enterprise with in-house staff and outsourced expertise. Develop ways of combining data from different parts of the business. That is, for example, from your quality, logistics, and engineering functions, and apply these methods to as many domains as possible, particularly those that differentiate your company or attract customers. Learn to get value out of data through intelligent systems design using real-time analytics to tailor products to consumers and continually improve your processes. Think big but start small with proof of concept projects. Transfer into digital enterprise. Capturing the full potential of Industry 4.0 will probably involve major changes to your company's practices and the attitudes underlying them. Set the tone for the top with clear leadership commitment and vision from the CEOs and financial stakeholders. Foster the digital culture. All the employees will need to think and act like technologically adept natives, willing to experiment, learn new ways of cooperating and operating, and adapt everyday processes accordingly. Remember that change does not stop once the company implements Industry 4.0. The company will need to reinvent its capabilities continually at faster rates than in the past to stay ahead of the game. Adopt an ecosystem perspective. Develop complete product and services solutions for the customers. Use partnerships or align with platforms if you cannot develop a comprehensive offering on your own. You may find difficult to share knowledge with other companies and you may prefer acquisition to collaboration. But look for ways to bridge your company's boundaries, perhaps with technical standards, so that you can profit from being part of the platforms that you don't fully control. The greatest breakthroughs in performance occur when you actively understand consumer behavior and can orchestrate a distinctive role for your company with a complex ecosystem of partners, suppliers, and customers. So far, this all was regarding Industry 4.0, the basics and its technologies and how we can start with Industry 4.0. Henceforth, we will see how the technologies, that is, their implementation, can help industries to digitize their different departments. So first, we will start with digitally shop floor, that is shop floor which may become digitized using Industry 4.0 technologies. So digital shop floor. The vision of the digital shop floor requires development and integration of activities across the following complementary pillars. Digitally enhanced manufacturing equipment. Industry 4.0 hinges on the interconnection of machines and equipment in the cyber world as CPS systems. Currently, legacy machines are augmented based on the Internet of Things protocols in order to become a part of Industry 4.0 deployments. At the same time, new machines come with digital interfaces and act as CPS systems. In the medium or long term, machines will be digitally enhanced in order to provide embedded intelligence functionalities such as the ability to detect and remedy defects, to identify maintenance parameters, and to schedule maintenance activities and more. Such intelligence functionalities will provide machines with flexibility, reconfigurability, adaptability, and proactivity properties which are key enablers of the fully digital shop floor. Open digital platforms for automation and service engineering. In the digital shop floor, digitally enhanced machinery must be interconnected in order to support factory-wide processes. To this end, various digital manufacturing platforms shall be integrated based on Industry 4.0 and the digital shop floor vision functionalities. This is also important given that factories and machinery tend to deploy multiple rather than a single digital automation platform. Hence, the composition of multiple functionalities from different platforms is required in order to support end-to-end production processes as part of the digital shop floor. Interoperable digital components and technologies. The digital shop floor will be able to seamlessly integrate advanced digital and CPS technologies such as sensors, data analytics, and artificial intelligence algorithms. The digital shop floor will be flexible and continually upgradable with the best of breed of digital technologies for manufacturing. This is a key prerequisite for upgrading the intelligence of the plant floor with minimum disruption in production operations. Experimentation facilities including pilot lines and test beds. The transition to a fully digital shop floor requires heavy and continuous testing efforts as well as auditing against standards. Extensive testing is therefore required without disrupting existing operations as a means of guaranteeing smooth migration. To this end, there is a need for experimental facilities and pilot lines in which digital manufacturing developments can be tested and validated prior to their deployment in production. Open innovation processes. One of the major objectives of Industry 4.0 is to enable increased flexibility in digital automation deployments, not only in order to boost new production models such as mass customization, but also in order to ease innovation in digital automation. To this end, open innovation processes should be established over the interconnected digital platforms leveraging on IT innovation vehicles such as application programming interfaces, APIs, and the experimental facilities outlined above. The experimental facilities could serve as a sandbox for innovation. Creating a smart shop floor. The advanced technologies. Hello.
No, sir. I think someone joined with the microphone on.
The advanced technologies that monitor machine operations, gather data, and make decentralized decisions work in concert with employees to create what we call as smart shop floor. Ensuring the quality and reliability of products and processes, smart shop floor may include the following elements. Predictive maintenance. Sensors can monitor equipment during uptime and provide vital data to indicate potential issues or upcoming work or repairs that need to be made. This data assists teams in planning for required maintenance to avoid unnecessary downtime, reduces maintenance cost, and increases the availability of the machine. Predicting potential electrical failures can be difficult. Thermal imaging helps teams to visualize how mechanisms are heating or if parts are not running at normal temperatures. The data provided through predictive maintenance technologies can be valuable. Supplier partners can focus time and energy on maintaining equipment based on predicted maintenance events before a problem causes a breakdown. Machine sensors and transmitters. Sensors and transmitters enable machines to monitor internal processes and send alerts when a problem or potential problem arises. Standard sensors provide limited information about machine diagnostics. Smart sensors, on the other hand, offer advanced functionalities for automated machines that support regular maintenance or as well as troubleshoot potential problems. Original equipment manufacturers, that is OEMs, fabrication partners should be equipping welding and fabricating machines with smart sensors to detect when material is running low. This allows the machine operator and the material handling team to receive an alert and act accordingly. Rather than stopping the machine and waiting for new material to arrive, additional material can be delivered before the machine runs out the material. The data received from smart sensors offers virtually endless opportunities to not only to reduce downtime but to improve overall productivity and product quality. These smart sensors can also be programmed to detect smoke, noise, volatile organic components, that is VOCs, and other conditions to strengthen safety environments. Remote monitoring and signals. Lean manufacturing isn't a destination, it's a journey. As such, it is imperative to have the right tools and materials at the right time to operate most efficiently and effectively. Remote sensors ensure employees have what they need when they need it. For example, remote monitors and signals are being used to detect when materials or parts need to be refilled. When materials or parts are running low, an alert can be sent to personnel or a drone to restock the necessary parts and supporting an efficient parts flow. Real-time quality and safety data. Access to real-time quality and safety metrics helps employees do their jobs more efficiently and addresses issues before they become real problems that could impact product quality or on-time delivery to customers. The most accurate data informs proactive and intelligent decisions. Monitors with dynamic dashboards tracking key performance indicators can be placed throughout plants, providing all employees with immediate access to data. The availability of real-time data enables employees to see performance against productivity targets, quality metrics, and safety information. However, the data provided in real time goes far beyond improving productivity. In ensuring a digital shop floor along with necessary setups, do not lose the sight on security. It is a must to secure a company processes, data, product, manpower, and other essentials. So the next department is quality. It's a very, very important department because quality is something every person thinks before buying. QC tag on the product makes us mentally relaxed and gives us confidence to buy the product without any second thought. So quality needs features and technologies for the Industry 4.0 scenario to make products better and product processes uh, better in developing products that can have altogether different quality. So Boston Consulting Group, that is BCG, conducted a survey. As per the response, it can be seen that Quality 4.0 is applicable to almost every sector in value chain. So first and foremost, we'll consider manufacturing sector. Participants said that predictive quality, machine vision quality control, and digital standard operating procedure, that is DSOPs, to be the most important use cases in manufacturing. Predictive tools give manufacturers unprecedented power to analyze massive amounts of data and discover correlations between critical variables. These insights enable companies to address the root causes of problems anticipated. It has been observed that compared with manual inspection processes, machine vision technologies are less expensive to use and more effectively verify quality or detect quality issues at early stages of the production process. For their part, digital SOPs ensure that workers have the most up-to-date instructions. In addition to above-mentioned use cases in manufacturing by the participants, other significant manufacturing applications include automatic root cause analysis, machine-to-machine communication to enable self-adjustment of parameters, and real-time process simulations. These applications promote product and process quality while eliminating waste. Research and development department, that is R&D department. Companies can use quality technologies such as simulation testing and artificial intelligence AI to improve a design's robustness. For example, artificial intelligence supports failure modes and effective analysis. By enabling and improving preventive quality, these use cases helps eliminate potential failure points in the design of a product or process. In addition, companies can work with usage pattern data that sensors connected to the Internet of Things capture to improve the design of future products in ways that enhance quality by preventing failure. As per participants, agile product development to be the most important use case in research and development. By replacing the traditional waterfall approach to development with an agile way of working, a company can achieve significant time and cost reductions in the development process. Because the agile approach facilitates cross-functional collaboration, it promotes more robust designs and improved quality outcomes. Digital tools for virtual design are important enablers of agile. They promote quality by accelerating test and validation cycles and making field data more accessible. A major industrial goods company focused 90% of its quality 4.0 investments on agile product development. Its goal was not to deliver R&D projects on time and within the planned budget, but to also improve the quality of the product at launch. The initiative gave its success to three building blocks: a well-crafted change management plan to promote organizational buy-in, top management support, and external assistance in building capabilities. The impressive array of benefits included delivering projects within 50% of the traditional lead time, avoiding the typical 30% of cost overruns, and boosting morale. Service as after sales. Equipment in the field can communicate data regarding its condition to its manufacturers in real time via the Internet of Things. By analyzing the data, manufacturer can generate insights that serve as an early warning of potential breakdowns related to the product quality that could trigger warranty costs. A manufacturer can also enhance customer support by remotely diagnosing quality issues. For example, an equipment manufacturer stores field data centrally and uses artificial intelligence systems to identify potential failure before they occur, enabling its technicians to fix problems prior to a breakdown. Similarly, field technicians can use mobile digital solutions such as field service software to enhance preventive quality and upgrade the customer service and experience. Such tools help improve service quality by giving technicians the access to equipment histories, information on recent failure points, and service manuals that streamline diagnosis times and quote processes. Procurement. Digital dashboards that track supplier performance give visibility to data such as KPIs, that is key performance indicators, and quantities ordered and received. Companies can use data on supplier performance to assess where quality risk exists in the supply chain and deploy supplier development resources as needed. They can also use the data in procurement negotiations and contracting to boost their bottom line. Logistics and sales.
त्रासमध्ये
By,
डोक्यात
by applying big data analytics to planning, a company can improve its ability to forecast the production volume it requires and to enhance the quality of its service. The benefits arise from the greater accessibility of data and from the use of improved logistics to support data processing and make compelling presentations to decision makers. A process known as pick by light and the use of gloves equipped with barcode readers, simplifying a company's logistics and improve the quality of its performance by making the process more reliable and less subject to human error. Cross-functional. The most important use cases involving cross-functional collaborations, according to survey participants, are centralization of quality data and end-to-end quality management system and quality cost transparency. A company must combine data sets from the quality systems of multiple functions to generate insights and address critical pain points across functions. In many companies, achieving this objective will entail creating connections between quality systems that each function currently maintains separately. Supply chain management department in an organization plays a crucial supportive role to ensure uninterrupted manufacturing operations. As per the McKinsey, an American management consulting firm, the digitization of the supply chain enables companies to address the new requirements of the customers, the challenges on the supply side, as well as remaining expectations in efficiency improvement. Digitization brings about supply chain 4.0, which will be more faster. New approaches of product distribution reduce the delivery time of high runners to few hours. The basis for these services is built by advanced forecasting approaches. Example, predictive analytics of internal, that is demand, and external, that is market trends, weather, school vacation, construction indices, data as well as machine status data for spare parts demand and provides a much more precise forecast of customer demand. Forecasts are not carried out on monthly basis but weekly basis and for the very fast moving products even every day. In the future, we will see predictive shipping, for which Amazon holds a patent. Products are shipped before the customer places an order. The customer order is later on matched with a shipment that is already in the logistic network, and the shipment is rerouted to the exact customer destination. This soon will be tested and implemented by Amazon. Supply chain will be more flexible. Ad hoc, that is when needed, and real-time planning allows a flexible reaction to changing demand or supply situations. Planning cycles and frozen periods are minimized, and planning becomes a continuous process that is able to react dynamically to changing requirements or constraints. Once the products are sent, increased flexibility in the delivery processes allows customers to reroute shipments to the most convenient destination. New business models such as supply chain as a service for supply chain function planning functions or transport management increase the flexibility in the supply chain organization. Soon we will see an Uberization of transport, crowdsourced flexible transport capacity, which will lead to significant increase in agility in distribution networks. Supply chain will be more granular. The demand for customers for more and more individualized products is continuously increasing. That gives a strong push towards micro-segmentation, and mass customization ideas will finally be implemented. 3D printing helps in mass customization. Customers are managed in much more granular clusters, and a broad spectrum of suited products will be offered. This enables customers to select one of multiple logistic menus that exactly fits their need. New transport concepts such as drone delivery will allow companies to manage last mile effectively for single and highly dense value packages. Supply chains will be more accurate. The next generation of performance management systems provide real-time and end-to-end transparency throughout the supply chain. The span of information reaches from synthesized top KPIs such as overall service level to very granular process data such as exact position of trucks in the network. This range of data provides a joint information basis for the levels of seniority and functions in the supply chain. The integration of data suppliers, service providers, etc. in a supply chain cloud ensures that all stakeholders steer and decide based on the same facts. In digital performance management systems, clean sheet models for warehousing, transport, or inventory are used to set targets automatically. To keep the aspiration targets, also in case of supply chain distribution disruptions, systems will automatically adjust targets that cannot be achieved anymore to a realistic aspiration level. We will see performance management systems that learn to automatically identify tasks, risks, or exceptions and will change supply chain parameters in a closed loop learning approach to mitigate them. That enables automatic performance management control tower to handle a broad spectrum of expectations without human involvement and to only leverage the human planner for the disruptive events or new events. So this will automatically eliminate human intervention, which will be more, so because of which the system will be more accurate and productive. With this, the supply chain is continuously developing towards its efficient frontier. And the last and not the least, supply chains will be more efficient. Efficiency in the supply chain is boosted by the automation of both physical tasks and planning. Robots handle the material, that is pallet or boxes, as well as single pieces, completely automatically along the warehouse processes. For receiving or unloading to putting away to pick, pack, and ship, autonomous trucks transport the products within the network. To optimize truck utilization and increase transport flexibility, cross-company transport optimization is applied to share capacities between companies. The network setup itself is continuously optimized to ensure an optimal fit to business requirements. To create the ideal workload in the supply chain, various transparency and dynamic planning approaches are leveraged to drive advanced demand shaping activities, that is, special offers for delivery time slots with low truck utilization. Distribution centers or warehouses using Industry 4.0 technologies. Advancements in Industry 4.0 technologies have made it possible for distribution centers to leverage both standalone and integrated automation and other robotic technologies for truly intelligent systems while working safely alongside humans. Many new Industry 4.0 driven technological advancements such as vision picking are evolutions of current technologies such as voice picking deemed to be standard capabilities in most technologically current distribution centers. Several other more novel technologies are in the development phases and maybe only a few years away from widespread use. Each, however, harnesses smart industry technologies such as sensors, artificial intelligence, augmented reality, and autonomous vehicles to create more adaptable facility. So notable technologies include vision, vision picking from voice picking via augmented reality. So what is voice picking? Also known as voice directed warehousing, voice picking uses speech recognition to direct warehouse workers where to go and how to go to find desired objects in distribution centers. Using voice picking rather than scanning barcodes and completing paper documentation or typing in computer system frees up workers' hands and enable them to work more efficiently and quickly. Voice-centric solutions have developed distribution center operations, redefine and streamline processes and further reduce operational costs. Further, productivity gains achieved from voice picking include improved accuracy in processes such as replenishment, that is refilling, processing and loading. Voice picking can also improve worker flexibility, enabling them to condense tasks and work across multiple warehouses to cope with seasonality. So what is vision picking? Vision picking represents an evolution in the process towards less standardized activities. Vision picking also uses augmented reality to overlay graphical images over workers' line of vision, enhancing the view of physical objects with additional information and providing digital information about physical objects. Vision picking often also provides a real-time user interface capability with objects and digital devices and can be used with warehousing operations, transportation optimization, last mile delivery and enhanced value-added services. Although augmented reality and vision picking are in relatively early stages of adoption in logistics, the technology could offer significant benefits. It can help users to find objects faster and more effectively and accurately, reducing cost and lower inefficiencies. Companies such as DHL and Ricoh, for example, tested the devices in Netherlands warehouses and observed 25% increase in picking efficiency during the testing period. The process is also hands-free, scanner-free and paper-free and has the potential to reduce training time for new employees and bridge language barriers with staff. It can also reduce the need to segregate different types of products as well as help to identify the precise positioning of one case among many. This can greatly impact warehouse layout and receiving and put away productivities. Adaptive robots and connected automated guided vehicles. Although assembly lines and automation work fine for repetitive tasks, changes in shopping behaviors, increasingly complex demands on distribution centers, and the wide variety of objects contained in a facility necessitate a smarter, more flexible solution. Typically, automated guided vehicles (AGVs) are used to transport goods throughout the warehouse by following markers or other navigation guides. These advanced sensor technologies, coupled with connectivity, enables robots to adjust to their surroundings and even correct for errors they may encounter. Establishing a digital record about the physical environment and using it to generate how they move about the physical space. Amazon Robotics, formerly Kiva Systems, has designed robots to move racks irrespective of product size and shape of objects within the racks. The robots, called as pods, are controlled by a centralized computer using a secured Wi-Fi network for communication. They use infrared technology for obstacle detection and floor cameras to read QR codes on the ground to determine their location and direction. The key to the robotic warehouse's success is not the robot, but the brain behind the system. Robots can learn, self-adjust, and crowdsource. Amazon uses the robots in its distribution centers, stating that they improve productivity and jobs within its warehouses. By the second half of 2025, by the second half of 2015, Amazon had deployed more than 30,000 of these robots across 13 facilities. The Amazon robotic system can also point workers to objects within the factory, speeding picking processes, and can self-organize the warehouse. While the Amazon robotic system is proprietary, similar technologies are available more broadly, such as those that can pick individual items from shelves or work alongside humans, gathering the objects they pick manually. Semi-autonomous, flexible machines for value-added services. Several companies are also working on automating outbound packaging, that is bag or box, shipping and gift wrapping or unit picking. One sensor manufacturer has designed a universal final packaging machine using sensor detection technology with automatic format adjustment capabilities. The sensors embedded in these machines can detect changes in product characteristics such as size and shape and automatically notify the control system to reset the packaging configuration to ensure the correct packing box is used. The smart automated process reduces the time required to manually change configuration, adjust the machine, and put the machine back into operation. Additionally, in cases of incorrect classification, the product is automatically rejected without having to stop the system, reducing the productivity slowdowns. In these cases, sensors provide digital information about physical conditions. That digital information enables the machines to adjust its physical movement accordingly. The sensors also provide data to enable predictive maintenance. Fully automated picking and quality assurance. Fully automated picking and quality assurance to adjust to rapid changes in demand while many tasks such as visual recognition are still better done by humans. Current developments in advanced automated technologies may begin to tip the balance towards machines. For example, companies such as Dematic and Invata Intralogistics are working on multi-shuttle technology targeted to DCs, that is distribution centers, experiencing rapid growth and changes in product demand profiles. The system is flexible and can adapt to almost any shape or size building, including existing buildings with lower ceilings. Another organization is working on fully automated picking with its Pick It Easy robot. The device has image recognition and processing capabilities. The device is highly flexible and can accept almost any dimension of source containers. The company is also working on developing, receiving, and order picking validation technology which can perform full checks of articles picked automatically, ensuring higher inbound processing accuracy. Next generation distribution operation centers or systems. The increasing focus on omni-channel capabilities places great pressure on distribution centers to keep up with a higher number of orders, including rapid processing to improve economies of scale and ensure high throughput. These throughput pressures are paving the way for the emergence of new modular technologies that bridge real-time automated materials handling systems on the floor, including warehouse control software, programmable logic controllers, and electrical systems, and complex transactional systems that manage orders, customers, and inventory. These technologies include warehouse execution systems, that is WES, optimize warehouse performance by constantly monitoring automated assets and balancing them through changes in order to fulfill requirements and labor resources. Smart automated facility management for greater efficiency. Industry 4.0 technologies are also finding applications within distribution center facility management. For example, complex and intelligent management systems can be remotely controlled to closely monitor environmental features such as humidity or HVAC, that is high voltage air conditioning, to maximize energy efficiency. Sensors can be used by Internet of Thing applications to gather data about operating conditions. These data points are then analyzed to proactively manage buildings to better ensure efficiency. Those technologies also enable the identification of different layers of the building to analyze possible interdependence between systems, services, and operations. IoT applications and cloud-based devices are expected to ease building management. Safety enhancements and modularity. Safety enhancement is a crucial feature of robot actuation and sensors, enabling highly automated technologies to operate in an environment in which human and robots can work together. Embedded sensors automatically detect when a human enters or approaches their zone and immediately adjust robots' activity to promote human safety. Human and robots can then work in collaboration in distribution centers. These technologies maximize machine efficiency while allowing for more flexible operations and digitally analyze data to adjust physical movement and improve safety. Moreover, Industry 4.0 uses programming of automation equipment with capabilities such as over-the-air updates. It also paves the way for modularity, allowing robots to self-reconfigure to perform different tasks and to adapt to new conditions. Robots can thus evolve in a constantly changing distribution center environment by dynamically tailoring themselves to various tasks and being redeployed on different duties as needed without more programming or integration. They can also adapt to hazardous environments and handle items of various sizes and positions. So just let us understand how Industry 4.0 benefits the consumer. Better diagnostics. Perhaps one of the most frustrating issues for consumers today is when something goes wrong with their technology. On the other hand, it might be something simple or it might be something complex. Better diagnostics on connected devices can allow technicians to access equipment remotely to provide guidance without a costly service call. In some cases, the device itself may even be able to offer solutions to fix simple issues. Products tailored more towards consumer needs. Most businesses are constantly making innovations and improvements to their products. But in many cases, their innovations actually make their products less user-friendly rather than more friendly. By having more insight on how consumers are actually using their products, businesses can better tailor their products to the needs of their consumers. This will ensure consumers' happiness. Here, smart products will come handy to gather the data, but using data analytics, the data should be extracted and analyzed to come up with better solutions. Better longevity. Most products require a complex system of pieces and parts to function. In, in most cases, if a single piece fails, the whole thing stops working. When a consumer buys an extensive product that does not last as long as they feel it should, they feel most likely not to buy from the company again. Industry 4.0 will allow businesses not to just see how their entire product is performing, but how component is performing in the product itself. This will allow them to quickly replace underperforming parts before the before the entire line is obsolete. Better inventory management. There is perhaps no greater challenge in any sales-driven business than inventory management. Sudden demand can come without warning and then dries up just as quickly. Then when businesses cannot get the inventory when they need it or when the demand is high, they lose business. And if they have too much inventory, they lose money. This shortfall eventually dries up prices which ultimately get passed on to the consumers. Industry 4.0 can not only help to better predict demand but can help businesses to better manage supply as well. Both are good signs for consumer. And the last and the not least is low prices which every consumer is looking for. Every time a business experiments with a new product, it costs something particularly if the product is a failure. Those costs generally get rolled into price of high performing products, which drives the price up. The more insight manufacturers have into the consumers what really want, the more insight manufacturers have what consumer exactly wants, the more they can create products correctly which will be a big sellers. The fewer failures they have, the fewer costs they have to roll into their successful product lines. So all in all, we can conclude that connected machines could increasingly be able to self-report problems and provide insights on ways to improve efficiency, improving quality and yields. Smart robotics capable of capturing production data can use those insights to predict downtime and prescribe corrective action accordingly. Data from augmented reality will have significant impact on research and development, giving consumers more of what they want, getting it them faster and cutting down on cost. A system that ultimately will drive innovation. So all we can conclude that Industry 4.0 is here with exciting opportunities and challenging new requirements. Thank you so much for your patience and time. I know it was mentally exhaustive because it was more informative. So I hope you got what I wanted to share. The crux of Industry 4.0 is all about digitization. The more we digitize the system, the more it will be better for everyone, that is the company, the employers, for consumers, and the machines and the whole system as such. Thank you so much once again for your patience and time. Appreciated. These are few references that I have used just for your reference.
Thank you, sir.
Thank you, sir.
If anybody wants to ask any questions, they can unmute themselves and they can ask. Actually, sir, we have a lot of things in the previous 4 days. So, lot of analogies and abbreviations like cobots and the things that we can actually correlate.
Yes, sir.
And it was quite informative and understanding too, because people already know some explanations regarding the few technologies also.
Okay.
So yeah,
No, it's good.
yeah.
Uh, just tell me again, how can I share the presentation?
Means to the participants.
I just wanted to show it. I guess I have removed. I want to share it again.
Yeah, yeah. Go back to again that share link. It's third from the right, the main
Right, right.
menu. Yeah,
Okay.
and
Okay, it's there
below
now.
once.
Yes,
Yeah,
yes.
yeah,
It's there. Okay.
yes. We are going to send one mail regarding the material that you want to share with all the participants.
Okay.
So I request you to please share that with us, and with your permission, we will share it with our participants.
I have already given references, the links and everything.
Yeah,
So I have used those links only to make this
yeah,
presentation and make it more informative. One
yeah,
can go through those links and get the
yeah,
more information in depth.
yeah.
If you still want, I can give it on Microsoft Words or something on
Yeah,
that.
definitely. Please, when I will send that mail today only,
Okay.
and we are going to collect the material from all the speakers, and
Okay.
we will put it on a Google Drive to share with
Fine.
the participants. Yeah.
No
So
problem. No.
yeah, whatever you want to share, please send it to me. I will share
Okay.
that mail.
Okay. No
Yeah.
problem.
Yes, sir. Uh, so participants,
Any
if it,
question?
yeah.
Uh,
Uh,
If anybody has a question, you can ask by unmute.
Sir, is there any certification for Industry 4.0?
Yes.
Certification just like
Yes.
ISO?
Uh, Obviously, every particular concept has its own certification, but Industry 4.0 as such, there is no certification, but there are courses and there are recommendations from big companies, but there are standards to implement Industry 4.0. So every company that, for example, if there is an ISO that we follow ISO standard. So likewise,
Yes, sir.
Industry 4.0 recommended standards are there, but there is nothing as sort that you have to have this certificate for the company or anything of that sort. Only the concept can be implemented in the company, but you
Acha.
have to follow ISO standards or TUV standards or what do you say, international standards, British standards, that is BSI is there. So that way you can implement in your company, but there is no any industry specific standard, industry 4.0 specific standard as such.
And how much is the scenario in India? Industry
It, i- it,
4.0?
it, it is improving. It is improving. Other people have started taking it seriously, but
Acha.
this corona, that is COVID-19, has affected it badly. So it will take another 2 to 3 years to, you know, get implemented at least 30 to 40%.
Acha.
Had not there been COVID, we would have started seeing Industry 4.0 by this year end.
Acha.
Yes, augment. If you go through the presentation, you will understand that rather automated guided vehicles are already
Yes,
there in
yes,
the
yes, yes, I
company.
remember.
Hello.
Okay.
uh, yes,
Hello.
yes,
ठीक
sir.
है ठीक है
Go ahead.
Hello. Uh,
नहीं 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 अगर केयर लिस्ट में होगा तो अदरवाइज नहीं
I think someone is using cell
केयर लिस्ट
phone.
में है क्या
Hello.
Yes, sir. I think someone was using cell phone.
Okay.
No
Okay.
issues, no issues.
For industry for someone has asked about current status of industry 4.0 in India. So we can say that companies are implementing
Yes.
few of the technologies.
Mm-hmm.
Automated guided vehicles are already there. 3D printing has started picking its speed. 3D
Yes,
printers are
sir.
there, but the cost of
Yes.
printing is slightly on higher side at this moment. But
Mm-hmm.
eventually, the cost of printing will slow down and acceptance of 3D printing will grow.
Acha.
Further, you must be aware of Internet of Things, cloud computing. These things are there in the market at this
Yes,
moment.
sir. Yes, sir. Uh,
But collective digitization of the manufacturing setup will take
uh.
some time. Will take some time, definitely.
Thank you, sir.
Because
Thank
because
you.
let me put it in this way. Because
Mm.
India and China, if you consider another country, we have more population. We are labor intensive countries.
Yes.
So if we implement one technology, the consequences of the technology will be hazardous. That means more jobs will
Yes.
be gone. Will be gone. So
Mm.
companies have to see that also, that jobs won't get affected. At the same
Acha.
time, digitization will come into the picture.
Acha, sir. Yes.
So this is why India will slowly accept Industry 4.0, but it will take some time.
Yes, sir. Yes, sir. Sir, are you going to share the PPT presentation? It was nice, sir.
Yeah, it will be with the organizers. They
Okay.
said they will be sharing with the participants.
Okay, thank you, sir. Yes, sir.
Yes, sir. No problem.
Anybody wants to ask question?
Hello, sir.
Yes, please.
Hello.
Yes, please,
Sir,
sir.
for individual use for engineering college or personally, which 3D printer one should buy?
For colleges and individual, one should start with basic plastic printers known as FDM technology based printers or triple F, that is fused filament fabrication based technology. The printers are affordable and one can buy those printers and start understanding 3D printing technology, how it helps, how it creates the products, how it helps to customize the products basically. And once you understand the process, then you can go into more better technologies. This AAA for FDM technology is the basic one to understand 3D printing. Are you with me?
Yes, sir. Yes.
Yes, yes. So
Yes.
FDM and triple F technology is the basic one to understand. Once you understand that, then you will understand
Yeah.
3D printing in depth, or more depth. And then you will
Yeah.
understand the application of other 3D printing technologies and use cases. And then you can go for
Yes.
higher 3D printing, 3D printers.
So, can you suggest any brand for purchasing that one, sir? And cost of that one?
If you ask me, I'll say my brand only, no?
Okay, nice. Very
Yes, yes.
nice, sir.
We manufacture
Mhm.
3D printers. Our printers start with 12,000.
Okay, sir.
And yes, they are basic ones, and the higher one goes till 1 lakh, 1.25 lakhs, like that. But basic one to understand, we start with 12,000.
Okay, sir. Sir, can you share this address, yours, how to contact you for that purchasing?
Okay, you can take my number.
Just a minute, sir.
Yes, sir.
Yes, please.
Okay, sir. Please share.
866
Okay, sir.
99
Okay, sir.
811
Yes, sir.
66.
Okay, sir. Thank you.
And other number is
Sir.
770
Yes.
70
Yes, sir.
289
Sir.
330
Sir.
96.
Okay, sir.
I'll repeat the
Thank you, sir. It
numbers.
is.
I'll repeat
Yes,
the
sir.
numbers: 86699 81166, and the
Uh,
other one is 70289
Sir.
33096.
Okay. Thank you, sir. Thank you.
Okay, no problem. Thank you.
Okay, sir. Okay, sir.
Yes, yes, sir.
It is
Thank you.
official numbers or personal number, sir?
Both are official.
Okay. Thank you, sir.
Yes, sir.
Okay. Thank you, sir, for your
Yes, sir. No
information.
problem. Yes, sir. Thank you, sir. No problem.
Yes.
Anybody from participant want to ask question? Please ask.
Okay.
Yes,
Okay.
please.
So no questions are there. So I will be here to say vote of thanks to Mr. Yogesh. I will be. Uh, I am thankful that he has shared his perspectives and views and information about the Industry 4.0. Participants must have got insight into what is Industry 4.0. So I'm once again I will say thank you to Mr. Yogesh on behalf of NBN Segar School of Engineering. Thank you very much for sharing your valuable information.
Thank you, sir. Thank you.
If there is any if there is any query regarding the session, if participant asks us by email, then we will forward it to you, and then you
Definitely,
can
sir.
reply.
Definitely, definitely. No problem. I'm still here. If someone has questions,
Uh,
can ask.
uh,
For next 5 minutes, they can ask. I mean,
okay.
I'm okay. That's not an issue.
So, sir, can I again ask one question?
Yes, please. Yes, please.
How we can use 3D printers in household needs or in consumer needs?
Oh, okay. 3D printers can be used for decorating houses. You can decorate your rooms, living room, or any room. You can help 3D with the help of 3D printers. You can create projects for your kids, school projects. Then further, you can create useful items such as few items for kitchen or a few items for bedroom, and then you can start a small business with gift articles. You can make gift articles with 3D printing and sell them. So there is no restriction with 3D printing, as far as design is concerned.
Yes,
Any
sir.
design can be converted into an object
Yeah.
with 3D printing. We provide courses also. Our courses are helping students to understand 3D printing in depth, and they are also getting into the 3D printing technology with much better insights, because as I had a chance to pursue PhD in 3D printing. So
Yes, sir.
I got insights into 3D printing, and I'm transferring that knowledge to students, and my company is into this business since last 3.5 years. So we have gained we have gained more knowledge. So we have
Okay,
started
sir.
transferring that knowledge for the benefits of everyone. So 3D printing is for everything, right from medical to household appliances, medical, aerospace, automobile, even
Yes.
fashion industry, jewelry making, architecture, interior designing, archaeology, food industry. Everyone is using 3D printing. Recently
Yes, sir.
only, I gave a webinar on 3D printing,
Mm.
and we covered almost 8 different sectors using 3D printing.
Okay, sir.
So
No, very nice.
3D printing is for everyone, sir. Everyone for everything. Anything can
So,
be. Yes, sir.
duration of your this training program for this 3D printing learners and
Yeah,
cost of that one.
we basically conduct for 3 months and 6 months. 6 months we provide diploma. Three
Ah,
months is a basic course that costs 25,000, and diploma course costs 45,000, because we
six
give
months.
certificate. Yes, sir. And
Yes.
we provide job assistance. If possible, we try to take student in our company also on
Very nice.
internship basis. On internship basis.
Yeah, we are having mechatronics branch in our college, Terna Engineering College, Nerul. So, for
Yes, sir.
our students, it will be very useful information, sir.
Definitely, sir. Definitely, we can do that.
Okay, sir. Thank you, sir.
Pleasure, sir. Pleasure. Thank you so much. May I know your good name, please?
My name is Jnanobag Ghar.
Okay, sir. Thank you, sir. Thank you, sir. Yes, sir.
Belongs to mechanical department.
Okay, sir. You have my number now, so you can call me anytime.
Yes, sir. I will surely call you, sir.
Definitely, sir. Definitely. No problem. Anyone with any question, please feel free to ask.
Sir, regarding
Yes.
those internships,
Yes, sir.
will it be much means helpful to the mechanical students also?
Yes, sir.
So yeah, in third year or last year,
Yes, sir.
kind of.
Internships are helpful to everyone
Yeah,
from second year to fourth year, but we
preferably. Yeah.
insist we
Hmm.
insist students from third year second sem where they can take 3D printing as a seminar topic,
Okay.
and that will make life easier for them to take uh, project for last year. Project in 3D printing for last year. So they understand 3D printing in their seminar topics, and then they can implement that knowledge in getting projects in 3D printing in the last year of engineering.
Okay. Okay.
Yes,
That will be helpful. Yeah.
yes, sir, definitely. I know the session was mentally exhaustive.
Yeah.
So much information was given. So even if you have smallest of doubt or query or question, please don't hesitate to ask. Please ask. I am here to clear your doubts because Industry 4.0 is a big thing, very very big thing, and it will be there for next 30 to 40 years, for sure. At least 25 years for sure, because
Hmm.
earlier revolutions lasted for first revolution lasted for 100 years almost, second almost lasted for 100 years, third for almost 65 years, and you can see the revolutions stay for substantial time. So the technologies under Industry 4.0 need to be studied, need to be learned, and need to be implemented. So having said that, we need to have the understanding of the technologies, and while understanding the technologies or going through such sessions or webinars, don't hesitate to ask questions. Keep asking, then only you will be excited to learn these technologies. These are very, very important technologies for bright future, bright career, be it in jobs or businesses or even education sector. So,
Yeah.
so don't hesitate. I'm here. Ask your questions. Feel free to ask.
Sir, is there any way so that small manufacturing companies can implement these technologies? Because lack of fund is the basic problem, I think, in front of them.
Sir,
So,
the Industry 4.0 never asks you to have substantial funding. What it asks you to start somewhere with something. There are 10 technologies. For example, there is a mechanical company, a manufacturing one. If it does not need cloud computing, then don't use it, or don't use Internet of Things also, but use 3D printing, because 3D printing is a part of manufacturing. It helps to manufacture components. It helps to manufacture parts. So this way you can get into digital manufacturing. Along with CNC manufacturing, you can go into digital manufacturing with 3D printing. 3D printing helps you to serve material. If you are into an IT company, then you don't need 3D printing, but you need cloud computing, big data, then you need Internet of Things. So as per your capacity, as per your capabilities, and your financial strength and employee strength, you can go with small inputs. Go with Internet of Things initially. Go with
okay.
cloud computing. With such small things, you can be a part of Industry 4.0 and slowly and steadily implement it and become a big company eventually. So there is no rule that only big companies can go for Industry 4.0.
Okay.
Yes, sir.
Means basic idea behind the Industry 4.0 was like there will be a lot of automation and
Yes.
IoT kind of things.
Yes, sir. Yes,
So
sir.
the little bit perspective has changed through this session.
Yes, sir.
Yeah.
It's like a chingari पूरा पेड़ों का ये जला देती है, वो टाइप में कि भाई थोड़ा चालू
Yeah.
करो, it will spread
Yeah.
like anything.
Okay.
Because a first step is required. Everywhere we say first step is required. That first step
Yeah.
is starting somewhere with something, even a small thing.
Okay.
That is needed in Industry 4.0. It's very crucial. Yes, sir.
So is there any means handbook kind of thing or any literature to study? Means suppose if there is a food manufacturing firm, so and they want to implement or they want to start with this. So how to start means from where they should go, because not all of them are from engineering background, because a lot of my friends are means quite commerce side and they
Yes.
have their own firms. So
Yes.
if I want to recommend them, so from where they should start?
We offer Industry 4.0 consultancy. In that,
Okay.
we, as per the company, we study the company, their needs, their applications, their processes, and as per that, we provide them a comprehensive plan which help
Okay.
them to implement Industry 4.0 technologies.
Okay.
And even if it is a non-engineering company, that's not an issue, because the technology is provided by the under Industry 4.0 will be supported by engineering people only. So the implementation will be taken care by engineering people, and non-engineering companies can take the benefits only.
Okay. I will definitely try to circulate your number.
Yes, sir, definitely, sir. Yes, sir. Thank you. Hargude sir wants to speak, I guess. His video is visible, but his mic is off.
Uh, Sir, if you want to ask any
Hello.
question, please.
Yes, sir. Please, sir.
Yeah, yeah. Hello.
Yes, sir.
Are you
How are
listening?
you? Yes, I am
Yeah,
listening,
I'm
sir.
from the. I am Professor N.V. Rugde, Dean R&D from PVP Institute of Technology, Budgaon.
Yes, sir. Please tell
So
me,
my
sir.
question is, you have got a student internship program.
Yes, sir.
Will it have the two types of programs? One is at your campus and other will be at our campus. Is it possible?
Sir, internships
Hello.
we offer only to students who do our courses, sir.
So how? What's about the hands-on practice to the students in internship?
We have
Hello.
our company, we have our manufacturing company. So we ourselves
Hmm.
develop 3D printers. So we provide them hands-on experience there only.
Hands-on experience. Another
Others,
thing is that
yes, sir.
you might have gone through the curriculum of the all universities,
Right,
maybe
sir.
from the
Right, sir.
Pune. Uh, what do
Right,
you
sir.
think that how it is incorporated, Industry 4 or the mechatronics, automation in the curriculum? Because in manufacturing, you will find that up to the CNC it is all right. It
Right,
is
sir.
incorporated. What's
Right,
about
sir.
the 3D printing? Other major changes are there in the industry
Right, sir.
because industry needs such types of technocrats and graduates,
Right,
and
sir.
we are not in position to provide them the skills and knowledge
Right, sir.
which is desired by the industry. So
Right, sir.
how it can be incorporated?
Sir, we are in talks with few colleges to start our online 3D printing courses for their students.
Hmm.
And through those courses, we will be transferring the knowledge, which eventually will help them to understand 3D printing. Further, with those
Hmm.
colleges, we are in a process of setting a laboratory for the colleges
Yeah.
with our 3D printers. So,
Hmm.
whatever we'll be teaching the students can try their activities on the printers to get the technology thoroughly in their mind and the implementation of technology in real time projects. This is how only
No.
3D printing can be taught. Yes, sir.
So, yeah, we have. I have my one project batch who has, assembled and gone for the trial for the 3D printing at
Yes,
our
sir.
institute, and it
Yes,
is
sir.
successful,
Yes,
no
sir.
doubt. But
Yes, sir.
the thorough knowledge is not known to them.
Right, sir.
This
Right,
is
sir.
what the big question before me and them also. Though they
Sir.
have assembled and got the total know-how of the 3D printing machine,
Yes,
but
sir.
they are not knowing because
Yes, sir.
these components will be available in the market,
Right, sir.
the assembly things and all those things.
Right, sir.
But what my suggestion is that if it is possible for you that to request all universities that you incorporate such types of curriculum in the whole
Right, sir.
curriculum of the mechanical,
Right,
mechatronics
sir.
and all those things,
Right, sir.
then what had happened? No, conventional things must be now wiped out from the
Right, sir.
curriculum, and the
Right, sir.
new things must be incorporated
Right, sir.
because
Right,
they,
sir.
yeah, okay. This
Yeah.
so my request is for to you that one, you may start the theory classes maybe at the institute level and the hands-on practice at your end, because the students from Sangli, Kolhapur, and
Right, sir.
Solapur and all those things, they may not be in position to bear the cost of the training at
Right, sir.
Pune.
Right,
That
sir.
may be the possible solution. If you
Right,
have
sir.
any you send me to me my mail ID. So I will send my proposal to you on your mail ID. That will be the
So,
procedure.
so how can I have your email address, sir?
My mail ID is available on my portal of the institute. To take down my email ID, nvhargude, nvhargude,
Yes, sir.
nvhargude at the rate
Yes, sir.
pvpit at the rate
PVPI.
pvpit
Yes, sir.
Sangli
Sangli.
pvpit Sangli .edu.in
Okay.
.edu.in.
So may I have your
So
phone
please
number,
send
please?
my phone number 9890
9890
133
133
778
double three. After that
778.
778. Okay, 9890 133 778.
Yeah, okay. Sir,
Thanks.
for your kind information,
Yes.
our mechatronics lab is industry sponsored laboratory. We have got
Okay.
ample amount of the equipment with our mechatronics lab. But
Right, sir.
we want to set up, as per your suggestion, for the industry 4,
Yes, sir.
the 3D printing laboratory.
Yes, sir. Yes, sir.
So please cooperate me.
Yes, sir.
Though it is
I'll
not a part, but it is required for the students.
definitely, sir.
Okay.
I'll call you and I'll send an email also.
Okay. Okay.
Thank
Thank
you,
you,
sir.
sir.
Thank you so much, sir. Appreciate it. And hands-on experience is our main area of concern.
Yeah,
We
yeah.
try to.
That is. Yes, sir. It is now badly required for any
Yes,
graduate and
yes,
postgraduate student.
yes,
Hands-on
yes, sir.
practice. Most of the students have lost their hope so many years without
Yes, sir.
hands-on practice. Only theory they are getting, but hands-on
No,
practice is zero for them.
our courses are designed in such a way that theory class plus practical
Yeah,
combinedly, then after that they have to go through a project of creating, designing an object and then 3D printing
yeah,
it. So the student
yeah,
goes through the whole process of understanding first design, then 3D printing, then problems that come in 3D printing, how to resolve those 3D printing problems. Then part selection also we teach rather, which part to be selected, which not to be selected, and why not to be selected. Everything is covered in the courses so that exact part gets selected and student understand why the part is used. So that is how we have developed our 3D printing courses, because my PhD has taught me the knowledge that should be transferred to students and industry people. Yes, sir.
Okay, thank you, sir. Thank you very much for your
Yes, no problem.
valuable suggestions to me and the kind
Definitely.
cooperation
Yes,
that
sir.
you will extend to me in future
Definitely, sir.
also. Thank you.
For sure, sir. Definitely. Thank you so much.
Okay, thank you, sir.
Yes,
I
yes,
think we should conclude our session
yes, sir.
because all
Yes,
the
sir.
participant needs to
Yes.
join 2 o'clock again.
Okay, sir. No problem. No
Okay,
problem, sir.
yeah.
Yes,
Thank you. Thanks a lot, sir, for your
yes,
valuable
pleasure.
Yeah,
guidance.
sir.
Yeah.
Pleasure, sir. So, so shall I close from my end?
Yes, sir, please. I'm also going to close it. Okay.
Okay.
So all the participants, please note that we will meet again 2 o'clock with the session of Eknath Kulkarni, sir. Okay. Yeah.
Thank you.
Thank you. Thanks a
Yes,
lot,
sir.
sir. Yeah. I'm
Yes, sir.
closing now.
Okay. Hello, hello, hello.
Yes, sir.
Can I get the copy of this seminar also?
Seminar, I didn't get
I,
it.
I mean, this session, whatever we just had, industry. Can I
Yeah,
get the copy?
recording. Yes,
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 sir. Record.
definitely, sir. I will share the link with you. You can
Okay.
download it onto your end.
Thank you so much, sir. Thank you.
Yeah.
Thank you.
Yes.
Appreciate it.
Def-
Bye.
Yeah.
Bye.
Thank you, sir. Yeah.
Bye.
Thank you all.